Have you ever looked at a world map in a classroom or office? Maybe you've traced your finger along the continents, imagining faraway places, or planned a dream trip across the oceans. Maps are everywhere, on walls, in books, on our phones, and they seem to offer a clear, reliable window into our planet. It seems so official, so trustworthy. The colors are bright, the lines are crisp, and the names of countries and cities are neatly printed. It feels like you're looking at the real world, shrunk down to fit your wall. But what if I told you that map is telling you a little white lie, not a malicious one, but a necessary fib that comes with the territory of turning our round planet into something flat and easy to hang up? Every flat map of our round world has to bend the truth. It's a bit like trying to press a ball of dough into a perfect square. It just doesn't fit without some stretching or squishing. This isn't a conspiracy, it's a problem of geometry. The Earth is a sphere, and when you try to show it on a flat surface, you have to make choices about what to keep and what to change. You can't flatten a sphere without stretching or squishing some parts, just like you can't flatten an orange peel without tearing it. No matter how carefully you try, some pieces will end up bigger, smaller, or oddly shaped. The map on your wall is a powerful tool, but it's always a bit distorted. Some places look larger than they really are, while others shrink or twist in unexpected ways. This video will take you behind the scenes of map making, showing why your world map looks the way it does, and how those choices shape your view of the world. We'll explore the hidden decisions and clever tricks that cartographers use to make the world fit on a page. You'll see why some countries look gigantic while others appear tiny, even when that's not reality. Greenland, for example, often looks as big as Africa, but in truth Africa is about 14 times larger. Every map tells a story, emphasizing some features and downplaying others. The choices made by map makers can highlight certain countries, oceans, or even political ideas, while making others seem less important. Knowing this doesn't mean you should stop using maps, it means you can use them more intelligently. When you understand the tricks and compromises behind the map, you become a smarter explorer of the world. Start asking, who made this map? What was their goal? Was it for navigation, education, or maybe even persuasion? Why did they make it this way? What choices did they have to make, and what did they leave out? What is it showing me, and what is it hiding? Sometimes the most interesting parts of a map are the things you can't see at first glance. By the end, you'll see that a map is not just a picture, but a perspective and a story. It's a way of seeing the world, shaped by choices, priorities, and sometimes a little bit of friendly deception. Let's peel back the layers of the maps we thought we knew and discover the fascinating stories hidden in plain sight. Imagine peeling an orange. As you pull away the peel, you might try to press it flat on a table, but you'll quickly notice it just doesn't want to cooperate. No matter how hard you try, the peel crumples, tears, or overlaps. It simply refuses to lie flat without changing its shape. That's the same challenge every map maker faces, turning a three-dimensional globe, like our Earth, into a two-dimensional map that fits on a page or a screen. This process is called a map projection, and every projection distorts the Earth in some way. There's simply no way to flatten a sphere without stretching, squishing, or tearing something. Map makers must make tough choices about what to preserve. Should they keep shapes accurate, maintain true sizes, preserve distances, or ensure directions are correct? Unfortunately, it's impossible to keep all these qualities perfect at once. For example, a conformal projection keeps the shapes of countries and continents accurate, but it distorts their sizes, making some areas look much larger or smaller than they really are. An equal area projection, on the other hand, gets the sizes right, so each area on the map matches its true size on Earth. But the shapes of landmasses become stretched or squashed. No flat map can be both conformal and equal area at the same time. There's always a trade-off. And that's why different maps look so different from each other. The choice of projection depends on the map's purpose. A map for navigation might prioritize direction, while a map for comparing countries might focus on area. So, when you look at a world map, you're seeing a carefully constructed image, designed with specific goals in mind, but always with certain distortions built in. This isn't a failure of map making, it's a mathematical certainty, a result of the geometry of spheres and planes. Understanding this is the first step to reading maps critically. It helps you see beyond the surface and question what you're really looking at. Every map is an interpretation, not a perfect copy of reality. It's a creative solution to a tricky problem. It's a version of the truth, tailored for a specific use, whether that's education, navigation, or exploration. Knowing which version you're looking at and why it was made that way is essential for understanding the world through maps. The Mercator projection, created in 1569, is one of the most famous maps you've seen. It was designed for sailors, not classrooms. Its genius: any straight line is a constant compass bearing, making ocean navigation simple. That's why it became the standard for nautical charts and eventually classrooms. But to achieve this, Mercator had to stretch landmasses near the poles dramatically. Areas like Greenland and Alaska look huge, while equatorial regions shrink. This isn't a minor error, it's a massive distortion. Generations grew up with a warped mental image of the world. The map's convenience for sailors came at a high cost, a widespread misunderstanding of the true size and scale of continents. The Mercator's legacy is a world map that misleads as much as it guides. Let's see how the Mercator projection distorts reality. Greenland looks as big as Africa on the map, but Africa is actually 14 times larger. Alaska appears comparable to Brazil, but Brazil is over 5 times bigger. Europe often looks larger than South America, when South America is nearly twice its size. Scandinavia seems huge, but India is more than 3 times larger than all of Scandinavia combined. These distortions aren't just quirks, they're fundamental misrepresentations. The Northern Hemisphere, especially Europe, Russia, Canada, and the US, are visually exaggerated. Meanwhile, equatorial regions like Africa, South America, and India are shrunk. This isn't just an old map's oddity, it shapes how we perceive the world. When continents are misrepresented, so is their importance. The Mercator projection's visual tricks have real consequences for our understanding of global geography. It's not just about shapes and sizes, it's about how we see the world, and that view is often very wrong. Map distortions aren't just geometric, they shape our minds. When the Northern Hemisphere looks bigger, we subconsciously associate it with power and importance. Africa, with over 1 billion people, is shrunk to the size of Greenland, an island with just 57,000 people. This downplays Africa's vastness and diversity. The Mercator projection, born in Europe's age of exploration, visually reinforced Europe's centrality and dominance. Maps shape our mental geography, influencing how we see global issues and power. The choice of projection can affect education, politics, and even economic decisions. A map is never just a map, it's a tool for shaping thought. To fix Mercator's problems, mapmakers created alternatives. The Gall-Peters projection, popularized in the 1970s, shows countries with their correct relative sizes. Africa and South America finally look massive as they are. But the Peters projection distorts shapes. Land masses look stretched or squashed. It's fairer in area, but odd in appearance. Enter the Robinson projection, created in 1963 as a compromise. It doesn't strictly preserve size or shape, but minimizes both distortions for a more familiar look. The Robinson became popular for its balance. No dramatic errors, no extreme stretching. Still, it's a compromise, not perfection. The choice between Mercator, Peters, and Robinson depends on what you want: navigation, area accuracy, or visual balance. There's no single best map, just different tools for different jobs. Every projection tells a different story. Why are there so many map projections? Because maps are tools and each tool solves a different problem. A pilot might use a mnemonic projection to plot the shortest route, even if it distorts everything else. A statistician might use an equal area map to show population fairly. Textbooks and atlases often use compromise projections like Robinson or Winkel-Triple for a balanced view. The purpose of the map dictates which distortions are acceptable. Always ask, what was this map made for? There's no universally true map, only maps that are more or less useful for a specific task. The right map depends on the job. Map design choices go far beyond just picking a projection. They also involve decisions about what's placed at the top and what's put at the center of the map. These choices might seem minor, but they have a big impact on how we understand the world. Most maps you see put north at the top, but there's actually no scientific or geographic reason for this. It's simply a tradition that's been passed down over centuries, shaping our mental image of the world. The reason north-up maps became the standard is because European mapmakers who dominated the field for centuries chose to put themselves and their continent at the top. This decision was less about geography and more about perspective and power. Some maps challenge this by flipping the world, putting south at the top. While this is just as geographically correct, it can feel visually jarring because it goes against what we're used to seeing. But orientation isn't the only thing that matters. What's placed at the center of a map is just as important. Most world maps center on Europe, which means Asia and the Americas are often split at the edges, making them seem less connected. Maps made in China or the United States often put their own countries in the middle, reflecting a local perspective and sense of importance. These choices aren't neutral. They influence how we think about what's central, important, or even powerful in the world. A map centered on Europe subtly suggests that Europe is the world's focal point, reinforcing a Eurocentric worldview. But if you center a map on the Pacific Ocean, suddenly Asia and the Americas appear more connected, and Europe is pushed to the edge, changing the story the map tells. By shifting the center or orientation, a map can completely change our perception of global relationships and what regions seem most important. Every map, whether old or new, is a reflection of its maker's perspective, values, and sometimes even their biases. The way a map is oriented and centered might seem subtle, but it powerfully shapes how we see the world and our place within it. We've seen that every flat map distorts reality. There's no perfect way to show our round world on paper. The Mercator projection shaped our mental image for centuries, but it's full of illusions. Understanding map projections empowers us to be smarter map readers. Ask, what's being distorted? Why was this projection chosen? What's at the center and top? By questioning maps, we become active interpreters, not passive consumers. Try comparing different projections, Peters, Robinson, South Up, or centered on another continent. Each map adds a new perspective to the puzzle of our planet. The world is too big and complex for any one map to capture perfectly. By learning the language of maps, we can better navigate both the world and ideas. Keep exploring, keep questioning. The real world is even more fascinating than any map.